Okay, we're going to be doing the problem for the series n from 1 to infinity of n to the third over 5 to the n. We're going to figure out if this series converges or diverges. I'm going to be using the ratio test, which is the limit as n approaches infinity of a to the n plus 1 over a to the n, and if it's less than 1, it converges. If it's greater than 1, it diverges, and if it's equal to 1, it is inconclusive. So we're going to start out with just writing out the problem. So instead of n to the third, it's wherever n is, you put plus 1. So we have n plus 1 to the third over 5 to the n plus 1. Now that would be over n to the third over 5n. But since it's on top, since we multiply by the reciprocal, if it's a fraction over a fraction, and then we're going to FOIL out the n plus 1 to the third power, and we get n to the third plus 3n squared plus 3n plus 1, and then we rewrite it with what we have. So we have the limit as n approaches infinity of n to the third plus 3n squared plus 3n plus 1, and this 5n is going to cancel over here because the exponent 5 to the n plus 1 is just 5 to the n times 5, so those two are going to cancel. And then we're going to take the limit as n approaches infinity. So because we have infinity over infinity, we have to take L'Hopital's, which means we take the derivative of the top and bottom separately until we no longer have infinity. So we still have infinity over infinity. So we're going to take L'Hopital's again. We have 6 to the n plus 6 over 30n. Again, infinity over infinity, but it looks like it's going to cancel after that one. So we're going to have the limit as n approaches infinity of 6 over 30, which just cancels down to 1 over 5, which is less than 1. So the series converges by the ratio test.